Problem 21. A large cube has side length 7 cm. On each of its 6 faces, the 2 diagonals are drawn in red. The large cube is then cut into smaller cubes with side length 1 cm. How many small cubes will have at least one red line drawn on it? These are our options. Let's take a look at a cube that is 7 cm on each side and imagine it being cut into smaller cubes, each with 1 cm in size. So this is the cube we have that measures 7 cm on each side, and it makes up of smaller 1 cm cubes. Now, as the question describes, a red line is drawn across the face of the cube. Let's look closely. On one face, the red line faces how many cubes? Let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it has 14 cubes, but one cube is in common, so we mark it as 13 cubes. Since a cube has 6 faces, you might think the total number of cubes the red line passes through is 13 into 6, which gives us 78. But wait, there's a catch. Some cubes are being counted more than once because they lie on the edge or corner shared by 2 more faces. So there are 4 corner cubes on the front face and 4 on the back faces here. So in total there are 8 corner cubes. So they have been counted. 8 into 3 gives us 24 times, but they should only be counted once each. So that means 24 total counts minus 8 actual counts gives us 16 extra counts. Now subtract those extra counts from the original one. So we have 78 minus 16, which gives us 62. So the correct answer is option B, 62. Problem 22. Maurice asked the canteen chef for the recipe for his pancake. This is the recipe card. Maurice has 6 eggs, 400 grams of flour, 0.5 liters of milk, and 200 grams of butter. What is the largest number of pancakes he can make using this recipe? These are our options. For this problem, we will figure out how many pancakes we can make with each ingredient separately. Then we will take the smallest number. Why? Because if one ingredient runs out first, we can't make any more pancakes, even if we still have plenty of the others. So the limiting ingredients decides the total number of pancakes we can make. So let us solve this problem now. First, let us calculate how many eggs we can use to make pancakes with the available 6 eggs. So we are calculating eggs first. So from ingredient card, we know that 25 eggs can be used to make 100 pancakes. So it will take 1 egg to make 4 pancakes. 100 divided by 25 gives us 4 pancakes. And 6 eggs will make 24 pancakes. 6 multiplied by 4 gives us 24 pancakes. Similarly, we will calculate milk. We have 0.5 liters of milk available. From the ingredient card, we know that the 4-liter milk is used to make 100 pancakes. So 1 liter will take 25 pancakes. 100 divided by 4 gives us 25 pancakes. So 0.5 liters of milk will take 25 into 0.5 gives us 12.5 pancakes. Now let us move to flour. So we have 400 grams of flour. But from the ingredient cards, we know that we are measuring in terms of kg, kilograms. So we have to convert gram into kilogram. So when we have to convert the smaller unit to a bigger unit, we will divide. So we will divide 400 by 1000 makes it 0.4 kilogram. So we know that the 5 kg of flour makes 100 pancakes. So 1 kg will makes 100 divided by 5 gives us 20 pancakes, and 0.4 kilogram multiplied by 20 gives us 8 pancakes. Now let us move to butter. So we have 200 grams of butter available. Again, the unit here is gram and the ingredient shows us in kg, kilogram. So we will convert gram into kg. So we will divide 200 by 1000 makes us 0.2 kg. Now from ingredient card, we know that 1 kg butter makes 100 pancakes. So we are talking about butter, and 1 kg butter makes 100 pancakes. So 0.2 kg will make 0.2 into 100 gives 20 pancakes. Now we have calculated all the values. So we will take the lowest value, which is 8 pancakes, since Morris will run out of flour first. So the question says, what is the largest number of pancakes he can make using this recipe? That is 8 pancakes. So answer is B, 8. Problem 23. The picture shows 3 gears with a black gear tooth on each. Which picture shows the correct position of the black teeth after the small gear has turned a full turn clockwise? This is the picture of 3 gears and these are our options. Let's take a close look at the gears. We will count the number of the teeth in each gear and figure out how much they can rotate. Before that, we can determine the direction of the gears. The pink gear rotates clockwise. This means the purple gear will rotate anti-clockwise and the blue gear will rotate clockwise. So after determining the direction, let us count the number of the tooth on the pink gear. So we start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have 10 tooth in total on this gear. Now if the small gear makes one full turn clockwise, it goes through its 10 teeth. So after the full turn, the purple tooth will be at what position? Let us count. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 position. So this resembles option A, option B and option D. Option C and option E are eliminated. So now to confirm the final answer, let us count teeth on blue gear moving in a clockwise direction. So the black teeth will move 10 positions. So it will move 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the black teeth should be at this position. And that resembles option A. So option A is our final answer. Problem 24. Each shelf holds a total of 64 deciliters of apple juice. The bottles have 3 different sizes: small, medium and large. How many deciliters of apple juice does a medium bottle contain? These are our options. So a shelf is holding a 64 deciliters of apple juice. They have 3 different sizes: large, small and medium. We want to find out how many deciliters are in one medium bottle. Let us solve this problem. Let us define variable for these unknowns. So we call small as S, medium as M and large as L. Now from first shelf, this is the first shelf, this is second shelf and this is third shelf. So first shelf says we have 3 large and 4 small and the total of it is 64 deciliters. From second equation, it says we have 3 small plus 2 large plus 2 medium, and the total is 64. From third shelf, we know we have 6 small and 4 medium, and that makes us 64. Now let us divide this equation by 2 on both sides. So it will become 3s plus 2m is equal to 32. Now compare it with equation 2. So we have 3s plus 2m, we have 3s plus 2m, and we replace it with 32. So 32 plus 2l equals to 64. Now we subtract 32 from both sides. So it will become 2l, 32, l will get 16. So we have l equals to 16. Now we'll put this value of l in equation 1. So 3 multiplied by 16 plus 4s gives us 64. It is 48 plus 4s gives us 64. We subtract 48 from both sides. So it will become 16 s is equal to 4. So we got a value of s now. Let us put the value of s in equation 3. So it will become 12 plus 2m is equal to 32. 3 multiplied by 4 gives us 12. Now we subtract 12 from both sides. So it will become 2m is equal to 32 minus 12 gives us 20. And we divide by 2 on both sides, and m is 10. So a medium bottle contains 10 deciliters of apple juice. And the question asks about how many deciliters of apple juice does a medium bottle contain? So our answer is 10. And option D is our answer, 10. Problem 25. Anne, Bob, Karina, Dan and Ed are sitting at a round table. Anne is not next to Bob. Dan is next to Ed. And Bob is not next to Dan. Which two people are sitting next to Karina? These are our options. So let us solve this problem. Let us assume that this circle is a round table and this line marks as the position of 5 chairs. Now let us mark this chair with the numbers 2, 3, 4 and 5. Now consider Bob is sitting on chair 1. Now the question says Anne is not next to Bob. That means Anne is sitting on either chair 3rd or chair 4th. So the question says Dan must sit next to Ed and Bob is not next to Dan. The best option for Ed is to sit on chair 2 and Ed to sit on chair 3. This confirms that N must be on chair 4, leaving only chair 5 for Karina. So Karina ends up sitting between N and Bob. So our answer is option A, N and Bob. Problem 26. An apple and an orange weigh as much as pear and a peach. An apple and a pear weigh less than an orange and a peach. And a pear and an orange weigh less than an apple and peach. Which fruit is the heaviest? These are our options. So for this kind of problems, we will follow along the question and solve this equation. So here is our clean slate. Now from here we know that an apple and an orange weigh as much as pear and a peach. So that means apple plus orange is equal to same as pear and peach. Now, second statement says an apple and a pear weigh less than an orange and a peach. So that means apple and pear is less than orange and peach. And the third statement says a pear and an orange weigh less than an apple and a peach. That means this pear plus orange is less than apple and peach. Now if we add equation 1 and equation 2, it will look like this. We have less not equal to because less than takes the precedence over equal to. So it's like less than, greater than, equal to, and then the rest of the logical operators. So when we add here, we have apple plus orange, and in green we have apple plus pear, and the right side added as well. That means orange will cancel with the orange on the right side. Pear on the left side will cancel with pear on the right side. And now we left with 2 apple and 2 peaches. That means we divide by 2 on both sides, we get apple is less than peach. Now let us add equation 1 with equation 3 and see what the result is. Apple orange, pear plus orange, and pear peach and apple peach. Again, less than took the precedence. So here we have apple on left side cancel with apple on the right, and we have pear cancel with the pear on the right. Now we have 2 orange is less than 2 peach. We divide by 2 on both sides and it becomes orange is less than peach. Now let's add equation 2 and equation 3 and see what the result is. So both have the same operators. So it will remain less than. Now it will give us 2 pear because apple cancels with apple and orange cancels with orange. We get 2 pear and 2 peaches. And we divide by 2 on both sides, we get pear less than peach. So here we are not determining the order of these fruit with their weight, but we have to determine which fruit is the heaviest. So looking into these results, we say that apple is less than peach, orange is less than peach, pear is less than peach. That means peach is the heaviest. The answer is option C, peach. Problem 27. 200 balls are arranged in a row and are numbered from 1 to 201. Each ball is colored either green or red. Among any 10 consecutive balls, there are exactly 5 green balls. Ball number 1 is green. How many red balls are there in the row? These are our options. So we have to understand one thing. When it says among any 10 consecutive balls, there are exactly 5 green balls. What it means is that every 10 ball group has exactly 5 green and 5 red. And this works all the way through the row. So for example, consider a pattern where any 10 consecutive balls always contain exactly 5 green balls. So if we pick the number from 1 to 10, we find exactly 5 green balls. If we pick from 15 to 24, again there are exactly 5 green balls. So 4 here, 1 here. So this pattern follows the rule among any 10 consecutive balls there are exactly 5 green balls. Now let us try another pattern. So for instance, a pattern with 2 green ball and 2 red balls. So if we pick from ball 1 to 10 and we count the number of green balls, we see there are 6 green balls. So this pattern does not work. Next, let us try an alternating pattern. Green, red, green, red. In this pattern, every odd number ball is green. So we have 1 ball, 2, 3, 4, 5, 6. So we know that every odd ball is green and every even ball is red ball. So picking any 10 consecutive balls in this sequence gives exactly 5 green balls. So let us pick from here. So we pick from this to this 10 consecutive balls, and we see that 1, 2, 3, 4, 5. So this pattern will work. Now you can experiment and try creating your own pattern that will follow this rule. So any 10 consecutive ball must include exactly 5 green balls, and that is the rule. Now let us go back to pattern 1 and analyze it. We can group the balls and count how many red balls are there. We find there are 15 in this row, 15 in this row, and that means we have 6 rows. So we multiply 15 into 6, we get 90. So we have 90 balls here, and then we add 10 more balls, so we get 100 red balls. This process is really lengthy. Now let us solve using a mathematical approach for the alternating patterns. So here the sequence continues as green, red, green, red. So the odd number positions as explained is 1, 3, 5 and so on. Similarly, red ball is at the even position 4, 6. To count the total number of red balls, we simply count using the formula. So we know the position of the last ball, that will be 200, because the 201 would be green ball. So 200 divided by 2 gives us 100. So the number of red balls would be 100 balls. So our answer is option B, 100. Problem 28. Burnby transforms the number from 1 to 100 by the rule. Each number is replaced by the number obtained by adding the original number with the sum of its digits. Among the newly obtained numbers, how many are even? These are our options. So here is the rule Burnby talking about. For example, if the number is 23, the digits are 2 and 3. So add 2 and 3, it makes it 5. Now 23 plus 5 gives us 28, and that is an even number. So we have to check, is the new number even or odd? We want to figure out from 1 to 100 how many final numbers following this rule would be even. So doing it one by one would take forever. So instead, let's look for a pattern. So what do we know? So we know that original number plus sum of its digit would give us new number. So let's group the numbers together. So we'll group as 1 to 9, 10 to 19, 20 to 19, 30 to 19, 40 to 49, and so on. So if we find a pattern in this number, then the rest of the numbers will follow that pattern, and that is how we would be able to solve this problem. So let us see. If we put any number between 1 to 9 into this formula and see what the new number is, even or odd. So let's pick original number 5 plus sum of the digits, it's 5 as well, and new number becomes 10. That is an even number. Let's pick a even number 8. Sum of digits 8 gives us 16. It's even number. So any number in between 1 to 9 will always be a even number. Now let us try number between 10 to 19. So let's see 11. So original number is 11. Sum of the digit is 2. And the new number is 13. That is odd. Let's try 18. So original number is 18. Sum of its digit is 9. So 18 plus 9 gives us 27 odd. So any number in between 10 to 19 is odd. Between 20 to 29. So let's try 25. So 25 plus 7 gives us 32. That is even. Let's try 29. So 29 plus 11 gives us 40. That is even. So now this is even. So as such patterns going on, it should be odd and it should be even. So you can try with 30 group and 40 group, and you will see that all the numbers lying in between are odd and all the numbers lying in between is even. So what is the rule behind it? Let's clear the screen. So this is what the pattern is doing. So if the first digit of the number is even, like 2, 4, or 60, so either the number is odd or even, the digit sum is even or odd, new number will always be even. So let us try a few more numbers just to prove this pattern. Let us try 64. So the original number is 64, sum of the digit is 10, and the new number gives us 74. Let's try an odd number, 93. So the original number is 93, sum of its digit is 12, and the new number is 105. So it is an odd number. The first digit of the original number is odd as well. So now, among the newly obtained number, how many are even? So we know that 1 to 9 are 9 numbers. They are even. This is odd, and this is even, and this is even as well. So we have 1 to 9, and then we have 20 to 29, we have 40 to 49, we have 60 to 69, we have 80 to 89, and that's it. So we have 9 number plus 10 plus 10 plus 10 plus 10, and that gives us 49. So the answer is 49 even numbers from 1 to 100. That is option A, 49. Problem 29. In a group of 10 elves and trolls, each were given a token with a different number from 1 to 10 written upon it. They were each asked what number was on their token, and all answered with a number from 1 to 10. The sum of the answers was 36. Each troll told a lie and each elf told the truth. What is the smallest number of trolls there could be in the group? These are our options. Let us dive in this problem and solve it. What do we have is the total of the real numbers on the tokens. Since they all have different numbers from 1 to 10, the actual total of the token number is 1 plus 2 plus 3 to 10 gives us 55. But the total of their answers is only 36. Meaning 55 minus 36 gives us 19. So the difference is 19. So this means the trolls lied and together their incorrect answer reduced to the total by 19. So we have to find out what is the maximum reduction one troll can make. So each troll holds a real token number from 1 to 10. But when they lie, they give a different number, also from 1 to 10. So the maximum reduction one troll can cause is if they have the highest token but say the lowest number. So we could say that the reduction is equal to true number minus false number. So the maximum reduction is true minus false number they can do is 9. But we can't assume every troll can reduce by 9. It depends on what token they hold and what lie they tell. To minimize the number of trolls, we want each troll to cause as much reduction as possible. Let's try a few trolls count and see if their reduction can add up to 19. Let's give the 3 biggest number to trolls. So let's start with 10. So we have real number and we have fake number. So let's say real number is 10 and fake number is 1 and their difference is 9. But the difference is 19. So that is not enough. Let's try another next real number. So let's try real number 9 and say fake number is 1 and their difference is 9 minus 1 gives us 8. So 9 plus 8 gives us 17. Still not same. So we are behind 2 numbers. So what we can do, let's try the next number, 8. And let's say fake number is 6 and 8 minus 6 gives us 2. So 9 plus 8 plus 2 gives us 19. So we have 3 numbers. So there are smallest number of trolls would be 3. So our answer is option B, 3. Problem 30. Dale has a shape made up of 4 squares. He places the shape on a grid figure so that it completely covers 4 of the grid cells. Every time Dale does this, the number in the 4 covered cells increase by 1 as shown below. So this is the picture, and then when we dab on it, it will increase to 1. It starts with 0 in every cell of the grid. Dale places his shape several times as described. In the end, Dale hit some numbers with circle stickers. What number should be in the square marked by star? And this is the shape, and these are our options. For solving this problem, the trick is to dab 4 squares at a time. We will start from one corner of the grid and try to reach the target number. Once we achieve it, we will move on to the next area. So let us solve keeping this trick in mind. So we will start with the initial picture as it is. So initially it will be 0 as indicated in this question. The orange one are the numbers that is under the sticker, and the red one is the number which we have to find it out. Now let us dab this area since we have 3 here. So we dab 3 times in this square and it makes 3 all together. Next we see this number 2. So we dab in this area 2 times to make 0, 0 to 2. This will increase to 5, this will increase to 5, and we will have 2 2's in this square. Now we see the number 3 in here. So we dab one more time in this area to make this number 3. This will increase to 6. This will have 1 and 1. Now we see the number 1 in here. So we dab to make it 1 in this area to make this one 1. So along with that we have 2 and 2. Now the next number we see is 6. So we dab 3 times in this area and make it, extend it to 3 first. So it becomes 5, it becomes 4, 3, 3. Now we have number 2. So we will dab 2 times to make this area, 2 times to make this area, this cell 2. So this will increase to 5, this will increase to 5, and this will become 2. Now we have last number in here, that is 1. So we dab in this area to give it 1. So it becomes 1, so it becomes 6 as we verified. But the center number, this number underneath the star, that is 5. So our answer is option A. 5 is the number that is marked under the star. So with this, we wrap up Math Kangaroo 2021 Part C for grade 5 and 6. If you really enjoy these challenges and learn something new, don't forget to give this video a big thumbs up and subscribe for more fun, tricky and exciting math adventures. Thank you. See you in my next video. Bye.